Welcome back. This is CET 4483. Today I posted your homework number 3, and I just want to discuss a little bit about this homework so you have a better idea what to do. There are two problems. The problem 1 is about the wiring a local area network, and we want you to figure out how long those wires needs to be. Basically, we want you to let us know what is the minimum total length of cable or wire required for bus topology, tree topology, ring topology, and star topology. These are the ones that we studied, the topologies. So this is to practice that one. Now, here is the floor plan of this building. There's a closet, here's the elevator, and there are 7 offices on each side. And we want through an opening, you can bring that wire or cable and connect them to each office, right? And so let me put them basically for the bus. Right? If this is the elevator, and here's the closet, and these are the offices on both sides, and this is the corridor. Okay, for the bus, we want you to start the wire, the first floor, and go through the whole building. And usually you're not allowed to go inside the elevator shaft, so you go this way and go to the next floor, and then go to the 3rd floor and the 4th floor all the way to the 10th floor. And then tell me, well, I just showed you how to do it. Tell me what is the minimum wire required. Now, so you need to calculate the length of the wire. It is based on this one. Every office is 15 feet, so you got to count all the way up to here. Then this is 15 feet, 15 feet. This one is 10 feet, all right? And then you go all the way like this, and you calculate. Now, what's the difference between the ring and the bus? The ring, once you get to the 10th floor, you bring it down and connect them to the head. The tail should be connected to the tail. That would be the ring. And so you need to calculate wire on each floor and also wire that goes up. The tree topology, the way it is, you're going to have to establish through the 10th floor one major branch, and then on each floor you got to go through each office, one, second one, and the 3rd one, and the 4th one, and here, because each one has to be a tree topology. So, and then you go about 10 story. The star topology, that means you have to set up a server or a center in one of the floors. The key is in which floor. And then from there, you will have a direct line to each one of offices in each one of the floors. So I want you to basically calculate the total cable or wire required for each one of those topologies. The second problem is kind of straightforward, which we already have practiced some of this, a different form of this one in your homework number 2. It says, consider the transfer of a file containing 1 million 8-bit characters. So there are basically 8 million characters from one station to another. What is the total elapsed time and effective throughput for the following cases? A circuit switched star topology. Call setup time is negligible, and the data rate on the medium is 64 kilobit per second. Well, basically what you're saying, we have 2 stations. From station A, you want to transfer to station B. In switch circuit switching, you basically have the length of the message, which is 8 million characters, right? And then you have a data rate. So if you divide the length of the message by data rate, you get basically the answer to that question right away. Now the part B says, how about if we have a bus topology with two stations a distance d apart? Then a data rate of b bit per second and a frame size p with 80 bits of the overhead. Each frame is acknowledged with an 88-bit frame before the next is sent. The propagation speed on the bus is this much. So this is very straightforward. So you have a bus topology, all right? If you send a packet, the time it takes for this packet to arrive, deliver this packet, which means transmission time plus propagation time, and then you have an acknowledgement packet has to come here. And then you have to calculate for all the packages, because how many packets you're going to have, it's going to depend on your total message length, which is 8 million characters, and then your packet size. Your packet size, this problem we are saying, is the size P, which is 256 bits, but 80 bits of that is data. So you need to divide your total message by that and find out how many packets you need. And for each packet, you've got to calculate transmission time plus propagation time plus transmission time of the acknowledgement packet plus propagation time of that one. And you need to calculate and give me the number. The part C is talking about the ring. The ring, the way it works, if we have one station here, and then we have another station here, and if we say the distance is d, so you need to transmit the packet, right? You need to transmit the packet, then propagate into this station. After that, this packet gets propagated back to here, and this, by receiving this old packet, this station knows that the first packet has arrived because it has passed through this receiving station. That receiving station, usually what it does, it copies the content and let the packet go. So then this one absorbs that packet and puts another packet. The same way it repeats. Now, this, you can calculate the delivery time. However, we said there are number of stations on the way that each one takes 1 unit of the delay time. Well, always, number of stations, if there are 10 in this case, divided by the data rate gives you how much delay time due to repeaters we will experience. So you will need to calculate that into your total delivery of the packets. That's the whole homework. So I need you to practice this one, see if you can solve it, and once the due time comes, I'm going to solve this problem and post them prior to your exam. Your exam is going to be on 26th of February, so you will have all solutions for all problems, homework problems, prior to that one. And also I will discuss your exam in another lecture. All right, good luck, and please work on this one. If you have a question, email me. Thank you for your attention. See you in next lecture.